So welcome back, friends. We are continuing with our discussion on the philosophical and theological implications of new physics. Actually, this is how we began with. I am just recapitulating whatever things we discussed in the past two sessions. That is to say, physics is challenging the very fundamentals with which we construct philosophy theology, namely space, time, matter, and laws of nature. Okay. Physics offers us a new epistemology itself. Physics has unraveled a new tension between history and transhistory, the temporal and the trans-temporal, the spatial and the trans-spatial. All that is supported with the epithet trans pertains to theology. Our argument has been that physics helps us anchor theology on the shores of metaphysics. I am sorry, I have some throat complaints. I am out of office also now. I am now in Northeast India. Some voice thrust is advised for me a little slow and short today. And my connectivity also is not that impressive. If there is some interruption, kindly hold on. We will hope to fix that one. Okay. Okay. So physics somehow brings us close to metaphysics. And that metaphysical nuances of physics is what is opening the gateway to theology. And the scientific routes for us towards this metaphysical enhancement was the revisioning of space, matter, and time. And even in that scenario, the principle of identity, principle of non-contradiction, these elements, fundamental principles of classical logic are challenged. And we will conclude this session today. And this was our hermeneutics. Kindly excuse me 1 minute. So, revisioning matter, space, and time from the perspective of modern physics. And where was this point I explained, I think. Okay. And the new understanding of matter, space, and time provides a scientifically plausible, rational credibility to several theological doctrines. So these are the theses that we started with. New understanding of soul, resurrection, eternity, Trinity, miracles. Yeah, mostly our discussion is confined to the Christian tradition, but this is not anything dogmatic. Our discussion is. This has interreligious implications, definitely, because whatever we say about matter, that is applicable across religion, the Judeo-Christian, Islamic, Hindu traditions as well. Especially the Eastern traditions, Eastern theological traditions come very close to what we discuss about the metaphysical nuances of the developments in new physics. This point also I wish to highlight. So our discussion on matter, which is extension in space and time, and in that our consideration of matter is nearly complete. Space was the focus of our attention in the last session. So this was what we discussed about space. Modern physics has advanced far beyond the Euclidean two-dimensional space to an Einsteinian curved space. And accordingly, maybe this element I will explain a little bit here. This was the focus of my attention last day. I jumped into this point as I wanted to complete that day, but I could not see. Multi-dimensionality, 0 dimension, 1 dimension, 2 dimension, 3 dimension, 10 dimensions. Space can have up to 10 dimensions. String theory says 11 dimensions. Some cosmological theories say up to 100 dimensions it can have. 1 dimension, a train moving on a track. Single dimensional, one-dimensional movement. Ship on the surface of the motion, width along with the length. 2-dimensional movement. Aeroplane, height also, along with length, width. These are the 3 possible dimensions of the universe. As the dimensions increase, greater and greater freedom of movement we experience. See, now we say, with quantum mechanics, multiple dimensions must be added to mathematics in order that our theories be self-consistent, which means whatever we consider to be inconsistent or illogical in classical epistemology go in vain. We have to have a completely new epistemology in understanding the ultimate state of affairs in physics. This brings us close to theology. This was our point. Okay, Einstein added the fourth dimension to space, that is time. And that is all about special relativity, the four-dimensional space-time continuum. Now, one more element I will add for the sake of our subsequent lectures in cosmology, that is about the idea of curved space in Einsteinian geometry. See, Einstein defined gravity as the curvature of this space-time continuum. You know, Newton considered gravitation to be the universal attraction between bodies. But how does this attraction take place? Einstein defined this attraction as the geometrical property of space. Space is not anything flat, but it is curved. Gravity, therefore, is the curvature of the space-time continuum due to the presence of mass. A massive body can curve the space-time continuum around it. A massive body can curve the space-time continuum around it. Let me ask, is my voice audio clear to you? As I said in the beginning, somehow suggested that I turn off my video. Should I do that? Am I clearly audible to you?
Yeah, yes, Father, you're audible.
Yeah,
okay,
but there's a little bit of disturbance now and then. I don't know
now
whether
it is
it's on
clear.
my
Okay,
side.
sometimes my connectivity is not that stable since I am off in
Thank you, Father.
interior place in the northeast. If something is not audible to me, kindly put your voice and let me bring it to my attention. I can try to rectify that. Okay.
Thank you, Father. Thank you.
Okay, you're asking me to make it full screen. No, I had a difficulty in moving the slides when I put it in full screen. Okay, let us see if it works. Yeah, this is fine. Okay, a massive body like a star, sun, or black hole, galaxies, they can curve the space-time continuum around it. Space-time is one, we discussed this point last time. Okay, such a giant body can curve the space around it. So simply we can say this is Euclidean geometry, flat space, say a plain paper with me. Now a galaxy is born into this one. So let me put my cell here. See what is happening to here because of the weight of the object here. This paper gets curved. Similarly, what we consider to be the space-time continuum is not that empty. This is something like an object, as though a net spread across. This is a thing, space-time. And when giant bodies are formed in space-time, they curve the space-time around it. Although light travels in straight line, when it passes through the curved space-time fabric of a galaxy or a star, it bends. This is an experimentally confirmed fact, the deflection of light in a gravitational framework. So Einsteinian idea of the curvature of the space-time continuum as generating gravity is a well-accepted theory. Okay, that is the revised understanding of gravity for space. Gravity as the geometrical property of space-time. Now, along with that, we must mention the concept of black hole also, although we will have some scientific discussions later on black hole and what we treat today. I just wish to introduce this concept to you. Black hole is a region, I know you are familiar with it because it's so popular a concept, black hole. A region where space-time is extremely curved due to extreme gravitational pull, attraction. So we said the bending is something like a small curvature only here. Now let me, if I put my paper, twist my paper in like manner as a cone, see, this is what a black hole is. What is causing such a black hole? The death of a massive giant star. There are particular principles of physics governing that. Those things we can explain later. When the inner core of the star is consumed out of fuel, the edges will be collapsing inward. That will generate a lot of gravitational pull energy release. That is what is constituting this black hole. At the bottom of a black, this is how we should imagine a black hole. Deformation of space and time. Those lines, what you see, they are space lines as well as time lines. Okay. See, even our Earth curves minimally the space-time curvature, space-time around us. That is why Earth has its own gravity. Now, black hole is the region where space-time is extremely curved, we said, formed by the death of stars mostly. Giant stars. Stars have three kinds of death, and massive stars much bigger than our sun, they end themselves up in black holes. And at the bottom of a black hole is said to be the most mysterious element in the universe, a singularity, a cosmological singularity. Singularity is a technical term, a point of limit or boundary where all the present known laws of science will be breaking down. A point beyond which science cannot advance. That is what we call as singularity. So black hole is such a thing. See, you see that red circle at the bottom of the black hole image, no? That is called the point of event horizon. Einstein says up to that point, a traveler can go into a black hole and come back. If you go beyond that point, you will never be able to return. You are entering singularity. We do not know what are the laws governing that state of affairs. Probably you are entering another universe, another world with the different laws of nature. Maybe some of you may have watched the film Interstellar by Christopher Nolan. If not, I would advise you should certainly watch as part of our curriculum itself. That is rich with philosophical insights. All the mysteries of physics that we are struggling here to understand, Christopher Nolan imaginatively communicates to us. Time travels, traveling through black holes, wormholes, curvature of space-time continuum, time dilation. These are the issues that we are using for theologizing basically here. Space-time mysteries. And Christopher Nolan has very well handled these things in a sensible manner, appealing even to the popular world. It may be a bit difficult for you to understand the story of Interstellar unless you read do some homework in the beginning. Okay. Nolan is not doing any theologization or philosophization there, but that helps us understand the physics of our reflections, basically. Okay. So singularity at the bottom of a black hole. Big Bang is said to be another singularity. Wormhole is another singularity. We will soon explain what a wormhole is. Okay. Nothing can come out of black hole. Said to be even light rays cannot escape from the black hole because of the extreme gravitational pull. A black hole can be as big as our solar system, it seems, supermassive black holes. It can be as small as Planck length also, 10 to the power of minus 39 meter. Extremely small. But such a minute object, black hole, can be as weighty as Mount Everest, it seems. How? Because weight is the pull of gravity on a body. And if black hole turns out to be formed out of in such a scenario, this will be as much, a black hole of such a size will be of as much weight, it seems. Because to come into that small size, it should have as much gravitational pull. Okay. And how many black holes are there? Perhaps millions and millions. Until some 10-15 years ago, scientists thought of our Milky Way as containing one black hole in its center. Now, some recent estimates say there may be even thousands and perhaps millions of black holes in our Milky Way itself. Black holes also are rotating in enormous speed. And Stephen Hawking made this foundational discovery. Although even light ray cannot escape from a black hole, there could be radiation from the black holes. That is what is called as Hawking radiation. That is because of the particular physics of black hole that we can, if necessary, we can have further details later. Okay, along with the black hole, I must just introduce the concept of gravitational waves also to you. This was also a prediction from Einstein that when there is collision between black holes in the outer space, that will generate ripples of gravity to be called as gravitational waves. They travel through space, not as electromagnetic waves travel through space. These gravitational waves, as they pass through space, they change the entire fabric of space-time that they travel through. Suppose we pour a cup of water on the floor. The water will be flowing over the floor without affecting the floor, except that it makes the floor wet. Now, this is not the case that the gravitational waves are moving through space. When gravitational waves enter the space, that affect the very fabric, the very nature and structure of that stuff. The floor itself is twisting and bending with the movement of the gravitational waves. We perform a dance on a stage. A dancer and a stage are distinct therein. But in the case of gravitational waves, the stage itself is turning into a movement of dance. That is how gravitational waves affect the space-time geometry. So with the discovery of gravitational, at that point I did not mention, no? So let us move to the next report. So this is what Einstein predicted with his general relativity. Something in the chat. Okay, questions I will take up as soon as my discussion is over. Unless it is a technical issue, I will, you can, if there is any technical problem with our discussion, kindly intimate me. And the question, certainly I will come back to you after a short while. So this is what Einstein predicted. You see on the top right, two dark image spots you find, no? Balls, they are two black holes. When they collide, gravitational waves, as though waves pass through a pond or a still lake, drop a stone onto a still pond, ripples are formed, waves are formed, is it not? That changes the very nature of the surface of the pond itself. This is the case with the gravitational waves also. They change the very nature of the structure of the space-time as well. And this gravity, Einstein predicted it, but scientific community was not certain until it was discovered in 2015 whether they exist at all. That was a theoretical prediction. And since then, scientific community has been in the hunt for the discovery of the gravitational waves. Finally, the discovery was made, and that made the headlines of the international news media in 2015. With this discovery was made with the help of the LIGO. This is an experimental device. This is a particular kind of laser technology that is used there. And see, the LIGO experiment has a 4-kilometer long tunnel and uses lasers to measure changes in the distance between the ends. See, this is the problem. It's full screen. Okay, slide one. Okay, this is the LIGO experimental setup, and 4-kilometer long L-shaped tunnels of the experimental lab. And what is the principle used here now? See, when gravitational waves enters, it stretches space and direction and it disperses space in another direction. That is to say, what we detected there was the gravitational ripples produced from the collision between two black holes that occurred 1.2 billion light years away from us. An event that occurred 1.2 billion light years in the past. Those waves have reached us. And as they reach us, their impact is very, very minimal because we are so far now. So in order to detect such a minute deviation, scientists developed a setup which can detect deviations to the scale of 10 to the power of minus 1/100th of a centimeter. Even such an absolutely small deviation of the laser ray can be detected by this LIGO device. The experimental setup is such that now to both ends of the LIGO device goes the laser beam. They should hit the other end of the tunnel and come back from both hands and should cancel each other at the meeting point. But the moment this device was turned on, gravitational waves were detected. How the waves did not cancel each other. That is to say, the direction of the and orientation of the waves were slightly deviated. There is nothing in the experimental setup that can impact such a deviation. This can be caused only by the modification of the space or the interference of the laser beams only resulting from the impact of the gravitational waves that is shaping the space-time fabric in that region. So when a gravitational waves enters, it stretches space and direction and it disperses space in another direction. By measuring interference of lasers as they bounce between the points, scientists can map if space has been compressed or stretched. Yeah, that is how gravitational waves were discovered. And this is a wonderful discovery, an epoch-making discovery. A new branch of astronomy is now open, gravitational wave astronomy. See, the major source of astronomy we will study in cosmology is optical astronomy. We study radiations in the cosmos. That is why originally we sent the Hubble Space Telescope. Now we have this James Webb Telescope, most advanced telescopes we have. They all use various kinds of radiation like infrared, visible light, all these things, alpha, gamma, beta radiations. Okay, radiation is the source of 90% of our astronomical information, but it has a limit. Only with the beginning of light, we can learn about the cosmos. And light originated only 300,000 years after Big Bang. So what happened between the first second in the history of the universe and the 300,000 years of the universe, scientists had only theoretical knowledge about that. Now we can really glimpse into those mysterious moments with the help of theoretically, experimentally. A new gateway is open into the inner recesses of the mysteries of the universe with gravitational astronomy. Okay, that is the significance of the discovery of the gravitational waves. So I am telling you, and we had organized an international conference on the philosophical, religious nuances of the gravitational wave, discovery of the gravitational under the leadership of Dr. Job Goldadam, who offers a previous course in Pune in 2016, nearly 6 months after the discovery of number of scientists, philosophers, and theologians interacted with this. And complex things are involved. They're not just scientific, but there are so many theological elements that we can easily decipher from this one. In tune with what we are discussing about. See, our bodies are ever in action. The matter, the solid matter that we are putting ourselves upon, that is ever in incessant action. Universe is extremely violent, basically a violent state of affairs. It is not at all static, essentially dynamic universe. So our very understanding of matter needs to be redefined. Gravitational waves also contribute to that in revisioning our idea of matter. Space is activity more than being simply an object. Time gets twisted very, very minimally because of the interference with the gravitational waves, because space and time are intertwined, as we have seen already. So here again, what we see, gravitational waves also, and the Einsteinian understanding of singularity or curved space, they all contribute to the revisioning of matter, space, and time. And this can be substantiated with the several philosophical insights, especially from the mystical traditions. The Eastern, especially the Hindu tradition, they consider space-time to be illusory, basically. We only construct space-time for ourselves. These are merely transitory, passing states of experience for us. Matter is an illusion for them. In the Buddhist mystical intuitive epistemology. I know I am only confusing you, but ultimately, finally, that is my goal also. When we do this sort of interdisciplinary discussion, we cannot have absolute clarity. Of course, as science and theology advances, we may be able to speak in more clearer terms, but as of now, we have to tolerate this vagueness. But anyway, these kinds of scientific discoveries bestow us with a lot of food for philosophical and theological religious reflections. That is what I am inclined to think. That's how I would appropriate these mysteries of the gravitational waves and so on. Okay, it implies significant implications for the very meaning of our corporeality. What we have been so far saying, the distinction between matter and spirit. Spirit is a theological term. I am using that license here. The distinction between matter and spirit slightly, at least minimally gets blurred with the foundational implications or philosophical nuances of the discovery of gravitational waves. And I can share more details with you later on through some notes, and so the proceedings of that conference also is published. I think maybe even that PDF I can make available to for those who are seriously interested in the philosophical religious implications of these sorts of topics. Okay, so multidimensionality, let's go. At this point, I have already explained. This is how Calabi and Yao, the two Japanese scientists, tried to represent string theory in 9 dimensions. Okay, so our discussion on matter and space ends here. Now I wish to add the recent relativistic finding on the understanding of time. Okay, maybe before I move to that, let me pick up the questions in the chat box. Okay, what is that? Why are black holes common in the ocean? 2 of my friends despaired in the black hole while that must be a whirlpool, Sister Jane. It cannot be a black hole.
Yes. What
black
is it?
hole occurs only in space.
Okay.
We can use the analogy, we can use it analogically that black holes more or less have the shape or figure of a whirlpool. That is all. That helps you understand what a black hole is. Otherwise, whirlpool has nothing to do with a black hole. That clarity. Okay.
Thank you, Father.
That is fine. Thanks for bringing up that analogy. That is very good. I hope you understood what black hole is there for.
Yeah, now.
Spatio-temporal property. Very good. Thank you.
Yeah.
Christopher, looks like a black hole is not space itself, rather an astronomical object that exists within space. Black hole can be observed and it is within space, right? Partly you are right, I think, but I don't know how you're conceiving that. Honestly, I must say, I also do not fully understand the entire physics and geometry of all these things. That is why we have arranged some interpersonal interaction with some professional scientists themselves in course of our course. See, this is space. As you imagine it, this is getting curved now. Even after curvature, only the shape has changed. Only the proper dimensions have changed, isn't it? The properties have changed. The space remains the same. Therefore, I think we need not distinguish between space and the curvature of the space. What is curvature cannot occur in vacuum. It is space that is getting curved. This remains space. Black hole can be observed and it is within space. Not that black hole is within space. Black hole is the curvature of the space itself. And a deformation of the space is what we call as black hole. Not that a deformation of the space is happening within space. I think that is not the right way of conceiving it. Because as far as the geometrical understanding of black hole goes, this is the deformation of space due to the presence of mass. Now, this massive body is within this deformed space. That is how we should conceive it. Okay, are there any other questions on black hole or Einsteinian understanding of gravity? And some gravitational waves I tried to explain to you very naively, and that is necessary for our theological understanding. That is okay. Then let me move on to the understanding of time. This we will finish up very fast. Okay. See, we said Einstein in his special relativity fused together both space and time. Time is not an independent reality as has been conceived in the Newtonian classical physics or in the Aristotelian physics. Until Einstein, space and time were considered to be two independent real objects existing eternally, possibly from the beginning. Of course, eternity has no beginning. Absolute flow, absolute space and absolute time. God originally created space and time. That was Newton's idea. Einstein said space and time cannot be separated. Time is only the fourth dimension of space. This point we explained last time. Then why do we revisit this point now? See, how can this be understood now? Einstein used the imagery of the clocks to show that our conventional understanding of time does not hold really for real time. Real time is only a mental construct, therefore. What is that? Relativity of time. Einstein said nothing can travel faster than light. If an object is traveling at the speed of light, this will turn out to be something like a photon particle. Our mass will undergo drastic change. Further, as the velocity increases, time will slow down. This is a very difficult concept to understand, but this has been experimentally confirmed. What is technically called as the dilation of clocks. As velocity increases, time will be slowing down. What does the relativity of time mean? What is the slowing down of clocks means? 1 hour means 60 minutes for all of us universally, is it not? But when 1 hour means 60 minutes for me, for you, 1 hour may be just 30 minutes. When 1 hour passed for me, for you, just half an hour passed. But the duration has been the same for us. Then why is there this difference? This is called the relativity of time. So velocity matters because I am in the stationary frame and you are in a fast moving frame. And if you are able to sorry, move at the speed of light, your time will stand still. As for me, it is 8:37 p.m. Indian Standard Time. Suppose we are in a fast-moving rocket, moving at the speed of light. This session will never come to an end because we will never reach 8:38 because time is going to stand still for an external observer. Okay, this is a bit complicated. Anyway, this has been experimentally proven with the help of atomic clocks, which can measure differences to the scale of 10 to the power of minus 42 followed by minus 10 followed by, 10 to the 42 zeros. One, I don't know how to say that one. Okay, such extremely minuscule differences in time can be measured. Two synchronized clocks, one clock placed on Earth, another clock was kept in a fast-moving space shuttle. 4 hours of flight. When later on, the measurement of time was taken on Earth between these two clocks. The clock in the rocket did show a slight dilation, which means time does slow down in a fast-moving rocket. Even while we travel by an aeroplane, time does slow down. But only thing is that we do not come to know that. Our watches cannot detect that slowing down. That is all. And this must be correlated with Einstein's own conviction on time. Time is something like a mental construct with no real objective existence. That is Einstein's idea. Depending on the frame of reference that you are in, the measurement of time will differ. An object that has one measurement of time in a stationary frame will have another measurement of time in an extremely fast-moving frame of reference. That is the relativity of time. Einstein wrote a letter from his own deathbed to the son of his friend Besso. Besso passed away recently, and Einstein is writing a condolence to this Besso's son. This is how the wording in the letter go. He has passed away a few days before me, but that means nothing. Persons like me who believe in physics know that the distinction between past, present, and future is a stubbornly persistent illusion. Got it, no? He has passed away a few days before me. That means nothing. I am a physicist. I believe that the distinction between past, present, future is an illusion. I don't know. Some say this may not be original to Einstein. This is debated. Anyways, Einstein had some similar mystical intuition about time, we need to say. Okay, Einstein's statement comes very close to some of the Eastern mystical understanding of time. They would say, some original text in Buddhist tradition, the creation of the universe resides not in a remote past, but in an eternal now. Universe is ever being created. How old the universe is? Not even a second. It is in eternal nowness. So, I myself not fully understand the nuances of what this Buddhist sages also and so on are saying. Anyway, they have some direct intuition into the fundamental nature of space, time, and so on by elevating their mental faculties to advanced level sizing. So there is a lot of discussion taking place between David Bohm, the renowned physicist, and Dalai Lama on this point. Dialogue between scientists and sages, a book by a scientist as well as a mystical writer, Rene Weber. You must read that book, very entertaining and very enjoyable. Top class scientists in the world, physicists mostly, including Stephen Hawking. is interviewed by her. And she is trying to make a rapprochement between the mystical intuitive traditions and the recent findings on space, time, matter, cosmos, and in modern physics and cosmology also. Dialogues between scientists and sages. Rene Weber. Also, The Dancing Boule Masters by Gary Zukav, Z-U-K-A-V. Gary Zukav, a Japanese physicist with a brilliant mystical blend of mind, exploring the analogical complementarity or parallels between the Eastern and the Western worldviews. In this context, I must also mention the controversial book, The Tao of Physics by Fritjof Capra, C-A-P-R-A. Fritjof Capra, The Tao of Physics. This is a world bestseller. Even several editions of this book was brought out. Millions of copies sold world over. It was very popular when it was published, but this is also criticized. What does it do now? It explored the commonalities in the worldviews between Eastern religious traditions and modern physics, the unity of the world, the dynamism of the cosmos, the interconnectedness of the cosmos, interpenetration of the universe, the commonalities in the understanding of space and time in modern physics and the Eastern traditions like Hinduism, Buddhism, Taoism, and so on. Okay, these are the various chapters in the Tao of Physics. Very interesting to read. But several scholars also have criticized Capra significantly for using too many parallels between, drawing too many parallels between Western science and Eastern religious worldviews. I would partly agree with these criticisms because, in fact, the true meaning of this intersection between the Western worldview, Western and Eastern worldview, is more metaphysical than cosmological. That is my submission. That is what I am inclined to think. But Capra is drawing too many cosmological parallels between the West and the East. In fact, that is not the point that the Eastern thinkers are or Eastern mystical writers are trying to give. They do not wish to prove that the cosmos is a harmony. Ultimately, for them, this is the emanation of the divine itself. The divine is not distinct from the world. This is the sort of idea they wish to give. Therefore, there is much more ontological and metaphysical depth for the Eastern religious worldviews, which is not anything the domain of the Western physics. Therefore, when we do East-West dialogue in terms of physics, we should be very careful with our methodologies, not to draw superficial parallels between the two. This point also I wish to caution you. While introducing these sort of ideas to you, the past, present, and future merging into an eternal nowness, which is said to have been a conviction of Einstein also. Okay. Again, the idea of virtual particles, particles which are not really existent but said to be existing virtually. They can be appropriated mathematically if only they are considered to be traveling backward in time. You know, our time has an arrow, a forward going arrow. But virtual particles challenge the arrow of time. Time can be meaningful if only, virtual particles can be meaningful if only they are considered to be traveling backward in time. Okay. That is what brought scientists to the concept of time travels. This is no mere science fiction. Some of the best brains in physics strained their brains on these kinds of contentious issues in science, in physics, with regard to the understanding of time. See, some of these pictures and slides that I am going to present to you now, they are literally adapted from Stephen Hawking's book. he is using this imagery. So this is what he says. The shape and direction of time. Einstein's theory of relativity, which agrees with a large number of experiments, shows that time and space are inextricably interconnected. One cannot curve space without involving time as well. Thus, time has a shape. However, it appears to also have a one-way direction, as the locomotives in the illustration show. Okay, time, see, it has only a forward-going direction, but it need not necessarily be an upward movement in time. See, it all begins with, let's say, begins with BC 2000. Now we are in AD 2024. The locomotive can descend from there to BC then. It is forward going, but the perception of time is backward therein. Such scenario we are forced to conceive in physics today. See, suppose you imagine, what they say is that time may not be like a single railway line, Hawking says, but may loop back on itself. How does a train turn backward? It has to take a loop, is it not? That is how. See, likewise may be time. That linear arrow may not reasonably work for time in all circumstances. It may loop back on itself. Suppose we hear an announcement at the railway station. The train now arriving at platform 1 already arrived half an hour ago. We might consider it nonsensical, but this is not nonsense. Best physicists of the world are making these kinds of imaginations. We are forced to reconceive time. There was a young lady of white who traveled much faster than light. She departed one day in a relative way and arrived on the previous night. We started our MTH in Religion and Science in 2023 and concluded our course in 2022. This lady is traveling faster than light. As of now, there is no theory justifying this travel, but it may be possible. If that scenario occurs, time will run backward for her. And she will depart on land back on the previous day that she started the journey. If the arrow of time is reversed in a contracting universe, then demolished buildings would rise up from the rubble and people would be born old and die young. Hawking says, an imaginary scenario in the reversal of the arrow of time. From the rubbles, the buildings may be restored, it seems. Our birth will be as old people and we will die as infants. Suppose you went back in time and killed your great-grandfather while he was a child. Good imagination. It is possible. Theoretically, as of now, we have no technique for that. Remain that these are hypothetical speculations based on some possible theoretical license that physicists are doing. These are not well-established concepts, but physicists are forced to devise the epistemology for that. In order, these are compulsions of their own mathematics, of their own theories, these kinds of ideas. Another concept, wormhole. Shortcuts between distant regions in space and time. Shortcuts between distant regions in space and time. In Interstellar, you will have a beautiful presentation of the idea of wormhole. This is how Christopher Nolan presents wormhole. 2 points in time. At the end of one paper here, and at the other end of the paper, I have put 2 points. Now, if an ant should walk from one end, from this end to this end, it has to travel a long way, is it not? But suppose that this end of the paper is now merged with this end and binding it. It is very easy to cross from this point to this point, is it not? There are regions in space where distant regions are so connected, it seems. Okay. There are regions in space where this distance regions are so proximate. Those connected regions we call what is connecting them? A wormhole. Wormhole is another singularity. If wormholes do exist, time will be running backward certainly in the wormholes, even the present mathematics and geometry. Okay. Okay. So with that, I am concluding my revisioning of matter, space, matter. Matter is extension in space and time. Therefore, we went for newly understanding space and time from the perspective of modern physics. Now let's do the synthesis. Let's go back to our original hypothesis. We said this new understanding sheds a lot of light on theological concepts. So, for instance, resurrection and eternity as non-linear phase transition in the evolutionary processes of the universe. Can we consider it so? Physics and metaphysics coming together. Physics are shedding light on the metaphysics of resurrection or the theological doctrine of resurrection. Science is not always, history is not always linear. Time does not move linearly alone. 1 + 1 is 2, 2 + 1 3, 3 + 1 4, 4 + 1 5. 5 + 1 need not necessarily be 6 always. As for nature, it can be 60 or 600 or 6,000. That is a phase transition in space and time. Can we consider that eternity or transcendence or glorification of matter is such a phase transition that is embedded in the laws of nature, in the physical laws of nature? This is exactly what Frank Tipler, the renowned physicist, has tried. He has published a book titled The Physics of Immortality. He is trying to understand the future of humanity and the future of life within the fabric of the contemporary physics. That is, the outcome is The Physics of Immortality, another bestseller. These are his arguments. But Tipler says, no, universe will ultimately collapse into a singularity of consciousness. Okay, all the information from universe is filled with information, overloaded with information. Is it not? Several laws are inbuilt in the cosmos, and universe is operating according to given laws. It is generating and processing newer and newer laws. There will be a bulk of information processing activity going on in the universe. Finally, only information will be remaining. Matter will be shed off from the universe. Information will be digitally existing. We no longer will require, universe no longer will require matter to exist. That would mean only consciousness alone will prevail. Possibly that could be a supercomputer, far different from our present idea of supercomputer and so on. Okay, the triumph of consciousness finally. And that he identifies with the theological concept of omega point. He calls that singularity as omega point. Here it comes much close to the Christian tradition, Judeo-Christian tradition, culmination in God, everything. Matter embracing spirit. Okay, and there are several arguments that he is posing in cosmological constants and fine-tuning. They are aimed towards a purpose, according to him. we will have one complete session on fine-tuning of the cosmos, but Tipler is using this argument. Then the arrow of time, a forward-going arrow. Certainly when Tipler published his work, he was not familiar with the non-linear arrow of time. Quantum mechanics and multiverse theory. So there may be other kinds of universes as rendered possible by quantum mechanics, where this kind of non-distinct matter and spirit may be existing. Technological advancement will take us to those domains. Information complexity explain this consciousness and information. So there will be a kind of digital immortality for universe, not only for humans, for the entire cosmos, there will be a digital immortality. Digital immortality, not that we individually are existing onto a computer, but as a whole, we're freed from matter, the glorified matter existing, surviving for eternity in another mode of being. Life will exist forever. It will survive both big crunch and big whimper. We will explain in cosmology that the end of the universe. Whatever the end of the universe, heat death or cold death, life will prevail. Life will be eternally exist. Okay, this has overlapping domains with theology. Okay, I just introduced to you Frank Tipler's idea also, since it goes hand in hand with the reflections, hermeneutical reflections that we were making. So this is our final synthesis. How do we understand miracles in this context? Miracles are not deviation from the laws of nature, or rather we should say miracles in this understanding is the actualization of a hitherto unknown law of nature. Laws of nature are enormously polyvalent, we said, extremely complex. We appropriate laws of nature only within our three-dimensional spatio-temporal fabric. But that is not the real fundamental fabric of nature. Physics sheds light on that. That was the point of our discussion. And there are several unimaginable, unknown, and almost unimaginable possibilities that laws of nature can be. Walking over the water, multiplication of laws, or chalk remaining unbroken even after breaking it. Laws of nature permit that. That is what we call as miracle. Our three-dimensional appropriation of a much more comprehensive idea of the law of nature, or much more integral actualization of an unknown law of nature, strange law of nature, we call as miracle in our worldview. That is all. I have found that Mark William Worthing, an Australian physicist and theologian, is also interpreting laws of nature along this line. He thinks that miracles need not necessarily be a violation of a law of nature. This is how Aristotelian Thomistic theology defined what a miracle is: violation of the law of nature. But does God violate the law that he himself has created? This is a philosophical issue. God need not violate any law. Miracle is another law of nature, actualization of another law of nature. God directly need not intervene there to perform a miracle. Rather, God has laid down the conditions or state of affairs or possibilities which renders any miracle possible in a particular circumstance. Not that God has no role in miracle. God is the foundational cause of the miracle as the author of the laws of nature. Likewise, we can be understanding miracles in this context. So, synthetic point second. We are as we are within this space-time, living only for 70, 80, 90 years. having a beginning and an end, temporal existence. 80 kg, 90 kg, 100 kg in mass, weight. We appear ourselves with this extension only because of the laws of nature that are defining our present properties. But this is not the only way that we can be. The different modes that we can be as rendered possible, justified by the polyvalent laws of nature, is probably what we are speculating in philosophy and theology. Thou art dust. Thou shalt return to dust. This is how the scriptural saying goes, no? We must reformulate it likewise. Thou art dust, but thou shalt not meant for returning to dust. You are not destined to doom finally, though you are made up of dust. You will have wings to fly. Thou shalt transcend. Matter shall be glorified. That is the idea. Eternity. Try to understand it within the fabric of the new understanding of relativistic understanding of time. Eternity has neither beginning nor end. It is eternal nowness. We cannot imagine even that scenario. But Einstein, that mystical intuition, had that wisdom. Soul, the spirituality of matter. You know, I will just bring in another popular scientific experiment. An American experiment conducted by American psychologists in the 1990s. I am a bit scared to quote this one because as academicians, we should go for fully verified and reliable experiment. Anyway, this is a scientific experiment, but questionable and dubious, I think. They planted two sets of plants, same feeding, same nurturing, and so on, except that for one set of plants, there was a group to pray for. After 6 months, the measurement of growth was taken. The set of plants which were prayed for showed some 10% of extra growth, higher growth it seems. For me, this is not a proof, scientific proof for the effectiveness of prayer. That is not how we should understand. Rather, this speaks for the ontological complementarity between spirit and matter. The non-distinction between matter and spirit, a point of our contention since the beginning of this lecture series. Okay, that is how we should try to understand it from the framework of physics, I think. This was the insight of Teilhard de Chardin. While in the Chinese desert performing and conducting experiments, researches, he was unable to celebrate the sacred mass. He would hold a handful of sand in his hand and say, "This is my body, take this all of you." His sacred attitude towards the particles of sand. About the handful of water, he will say, "This is my blood." Okay, basically, Teilhard had that mystical insight, a renowned scientist, a paleontologist. William Steger, American physicist, passed away, I think, in 2014 of cancer. A Jesuit theologian and scientist he had been. He says, in the past, we used to say about the distinction between matter and spirit, but the age of that distinction is now gone. Today, rather, we should speak about the non-distinction between what is God and, Today, we should speak about the distinction between what is God and what is not God. What does that mean? No? According to him, everything has been divinized to some extent. The spirituality of the entire creation, the re-sacralization, the re-enchantment of the entire cosmos. And the sixth point, we already have taken recourse to that. Several times we have cited Romans 8:28. Not only we humans who are the firstborns of creation, rather it is the entire physical material world that is groaning in birth pang for his redemption as the children of God. Very rarely only we find these kinds of cosmological, theological statement in the biblical tradition. But this is a very powerful statement. Christian theology should have been developing along this statement. But unfortunately, as a result of the apologetic contest in which Christian theology developed, as a result of the entanglement between the Western metaphysics, Greek metaphysics, and the Christian theology, these sort of cosmic mystical traditions did not develop adequately. Now, science is helping us to develop these sort of streams in theology. Remember what Matthew Fox told us in his special lecture to us, original blessing. Creation is a blessing. Okay, creation is beautiful. God saw creation beautiful. It is not a destruction or doom or death that is awaiting creation, but transcendence and glorification. So, dogmatic idea of Trinity, three being in one, maybe appear to be contradiction for us. Or is it a consequence of the epistemic limits of our perceptions? Our epistemology is far limited, is so limited even for appropriating the scientific information that we have. Science is struggling with the classical logic. They look for quantum logic. They try to develop quantum logic, meta logic, multidimensional space-time continuum, multidimensional space, how to appropriate it. Maybe principle of identity being challenged or principle of non-contradiction being challenged therein will not be nonsensical, at least. I am putting it in negative terms there. So what we need, therefore, is a new theological epistemology informed by natural sciences, more precisely physics. Okay, let me take up what is in the chat. Looks like black hole is not space. At that point we discussed. Okay. Please, I wish to be asked leave to pick a 6. Oh, please, Sister Jane, you can follow up this recording. I think that is all. Does anybody have any other comments or questions to make?
Yes, Father, we have to go through.
Very good, very good. I am fine that the system went on well. I was a bit apprehensive about that. I hope I make some sense to you, although everything may not be sensible and appealing to you. Anyway, this offers us a rational framework for understanding our faith. My faith is very much enhanced by these kinds of physical reflections as well. This is presented just for your consideration and try to appropriate and personalize it for yourself. If you have no further comments, I think we can wind up for today. And I also will be happy to wind up a little early today.
This is great.
Father Augustine,
Yeah, please.
Yeah, this is Michael.
Yes,
In
Michael,
your notes,
Michael. Welcome to you.
yeah.
You have been with us in the couple of times, but then we missed you. Welcome back, Michael.
Yeah, thank you. In your notes, can you put the names and authors of the books you mentioned? There was
Yeah, that is important. That is important. I will do that.
Okay, thank you.
Father Augustine,
Yes, please, Jerry.
have there been any theological schools that have incorporated this new epistemology? Or is this something that seems to be coming from your own Institute of Science and Religion?
Actually, I have tried to blend together a number of insights which I pick up from the recent publications in Science Religion Dialogue, and I have put in my own reflections also along with that. I would recommend, Professor, the publications of the CTN, the Center for Theology and Natural Sciences, and Vatican. They have a series of joint publications, no? Then I would also recommend the publications by Mark William Worthing, that Australian scholar in this line, no? His public reflections also go much along this line. And
So
what else I can think of? I will let you know if something else come to my mind, Professor.
This is the publication of the Theology and Science for those. who-
Yeah. CTNS publication.
Yeah, CTNS. Yeah, it's a very good publication.
Yeah.
But
I do
you're
receive the copy of that one.
Right. But I think most of the theological schools are still kind of in the past, not as advanced as you are.
Not quite. Yeah. We are. Yeah. This is a collective task. We have got to advance this reflections basically. At the same time, I always am careful not to cook up too much theology.
I have a
from
concern.
this. Yeah. Ferdinand, you wish to say something?
Yes, I have a concern here.
Okay.
Yes. Now, from my observation, okay, it's just an observation because if we look at our liturgical settings, I think we really need that bit of science. You know, people believe in the Bible, they read the Bible, but they do not know the reality, how things happen. The scientific part of it, if it can be put as part of research, just to inform the community what's all this about scientific findings, how we can relate it to our faith, so that people are not confused so much.
Yeah, very good. Ferdinand, thank you for that insight. Thank you for that suggestion. But what I picked up from here is that there should be more catechism along the scientific line that should reach out to our congregation. In fact, you know, Templeton Foundation had a project for science and religion in the pews. That is to say, how even homilies can be framed from us in an informed scientific manner. You will get a lot of stuff along this line of research from the web. Science and religion for the pews. So we need a revision of our catechism significantly. We need new rituals and symbols in our liturgy, basically, based on these kinds of reflections and developments. And this very well rediscovers indigenous symbols and cultures also, physics, therefore. And especially in Africa and so on, development of African theology will very well substantiate scientific theology. That is my submission. Yeah. Okay, friends, then bye for now. We will meet on next Friday.